Good morning, guys. It's Mrs. Duncan, and I am so sorry I am not here today. The stomach bug started going through my house this weekend, and my youngest has it currently, and she's 3, so I really need to be here for her. But I definitely wish I was there with you guys. I'll be checking my email all day, so please send me an email if you have a question, and I will do my best via email. I can make a drawing, a video. I'll do what I can to still help you guys from home. So don't be shy. Reach out. I'll be checking my phone until I go to bed tonight. All right, let's start off with some Regents exam information. It's tomorrow, so let's talk about what you guys need, etc. And then we're going to have a real quick lesson on the concept of photosynthesis and to what I seem to be able to have figured out, to what you guys should have to know about it for tomorrow's exam. All right, so when is the chemistry Regents? It's tomorrow, June 9th. Unfortunately, it's the afternoon one, so you guys will take your English in the morning, most of you. And then we're supposed to go at 12 p.m. is supposed to be the start time. So we're asking if you could try to get to gym 1. I'll be in gym 1 around 11:45 a.m. so we can begin promptly at 12. So gym 1, and I should be towards the left side, the very left side. Look for me. I'll be looking for you. What should you bring? Pencils, pens, and your calculator. I do have, as you know, I think I'm down to like 12 scientific calculators, which I can lend out on a first come, first serve basis. If you're going to need a calculator, though, you need to email me like yesterday to let me know, and I can reserve one for you. But graphing calculators are okay this year. So pens, pencils, and a calculator. If you do bring your graphing, we have to clear your memory, so just keep that in mind. Okay. Hopefully you have a single sheet photosynthesis and energy lesson. For some reason, I cannot record my annotations. I've been trying, so you're going to have to just kind of, I guess, listen along with me here. There's only really one thing you'd have to write down, so just get ready. You should know most of this already per your teachers from last year. Okay, so photosynthesis is the reaction that plants use to produce energy, and it's an endothermic reaction. It's one that absorbs / stores energy overall. So basically, the big concept here is that the light energy, and light energy is a form of electromagnetic radiation, like visible light is electromagnetic radiation. It gets converted to chemical energy, which is stored in the bonds of glucose. So endothermic reaction, electromagnetic radiation, light energy gets converted to chemical energy, which gets stored in the sugar bonds, the glucose bonds. So just a quick visual and a quick, I guess, review. This is an endothermic potential energy diagram. Actually, Mrs. Riley made this, not me. She teaches biology, but you can see glucose, aside from oxygen, the primary product of photosynthesis, is much higher in energy than the carbon dioxide and water from which it was formed. The reactants, they're much lower in energy. So yeah, that extra energy, that the difference between the glucose and the carbon dioxide and water, that extra energy that's absorbed is stored in the bonds of the glucose. So just remember, I think the big thing is to tie it back to the electromagnetic spectrum that's in your reference table here, is that sunlight is visible light, and it is a form of electromagnetic radiation. Plants absorb mostly red and blue visible wavelengths of energy, of light energy, also green, but they tend to reflect green, which is why leaves look green, but mostly red and blue. And again, the idea is that's a form of electromagnetic radiation, and it gets converted to the chemical energy, which is stored in the bonds of glucose. So photosynthesis reaction, there's that blue statement down there at the bottom. But basically, hopefully you remember this well enough from last year. The plant, oh gosh, you guys are I wish I was here so you could laugh at me. I believe it is the stoma in plants taking carbon dioxide gas from the atmosphere. Have not taken biology since 10th grade AP, forgive me. The roots pull in water, so those come into the plant cells. They are basically broken down. The bonds in the carbon dioxide and the water are broken down by the light energy. It breaks the bonds. It's absorbed. Barf, bond breaking, is an absorption of energy. And then when you form the glucose, the energy that's absorbed to break the bonds, more of it's absorbed overall than is released. When the glucose bonds form, that energy is stored in the bonds of glucose. So D-glucose is the specific type of glucose that plants make in their cells. So when you break those bonds, you get energy out, and then the plant can grow and do all its fun plant things. All right. So this is what I was hoping to label with the pen that I can't get to save my annotations. So here we go. This little pancake stack looking thing in the diagram, I think those are supposed to be plant stoma. Again, you can laugh at me, but I'm pretty sure those are plant stoma. And what we should see here is the stoma is taking in the above the first input next to the sunlight there. It's taking in the water, H2O. So above the first input arrow next to the sunlight, you could put H2O. That's the input. And the output from that is oxygen, O2. And then the second input over here to the right, you're going to have your carbon dioxide. I believe this circle of arrows is supposed to signify it's going through the Calvin cycle. Again, laugh at me. And then what comes out of that is the glucose, the C6H12O6, the sugar. All right, so one more time. The input on the left, that should be labeled as H2O. The output is O2, oxygen. The sunlight breaks the bonds in the water, allows the oxygen to be produced. And then the input over here on the right, you should have the CO2. It gets broken down by the sunlight, goes through the Krebs cycle, and then the output over here on the right should be the glucose, the sugar, the C6H12O2. All right, hopefully that's enough to get you through tomorrow's questions on photosynthesis. Carbon dioxide and water are broken down by light energy, electromagnetic radiation from the sun. They're ultimately converted into glucose and oxygen, and it's an endothermic process. Energy is stored in the bonds of the glucose. All right, a couple things to wrap it up. Email me. I will answer your questions as best as I'm able to from home. Second, I did post a practice test for every single unit I taught you, including nuclear chemistry. So I put the answers to all the short response questions in the hints on every single practice test. So if you've done some practice tests or you're thinking about doing unit practice tests, the answers to all the short response are in the hints. Email me. You're not bothering me. And I will get back to you ASAP. If it's a minute, it's probably because I'm at the doctor with my 3-year-old. All right. I miss you guys. I'm sorry I'm not there, but I will see you tomorrow. Bye.